that if I had 2 to the x equaling 2 to the 5, if the bases are the same, then the exponents have to be equal. And if there was an equation to solve, we'd solve the equation from there. But the majority of time when you're working with this stuff, you can't make the bases to be the same. Would be nice, but that's not going to happen. So then what do you do? What you tend to do, but it's very typical mathematically, they do it a little differently in intermediate algebra because they don't want to use the properties of logarithms at all. But if these two are the same, then we do the log thing. Then the log of the left-hand side has to be equal to the log. And you can pick any log you want. But I know that on my calculator I have log base 10 and log base e. You could use natural log because it's on your calculator, or you could use log base 10 because it's on your calculator. If you use a log other than base 10, like, well, could I use log base 2? Well, the answer is yes. But what's the problem? The problem is going to be is I'm going to need to be able to find log base 2 of 1.5 in order to get a numerical value. And that we know we have to use the change of base formula for, unless we have that program built into our calculator. Now, one side's 1.5, the other side is 2 to the minus x. Properties of log says bring the minus x down in front. This is how you get a hold of the exponent. Minus x times log of 2 equals the log of 1.5. I want x by itself. In order to get x by itself, I need to get rid of the minus, and I need to get rid of the log of 2. So I divide both sides by the opposite of the log of 2, so that x is equal to the log of 1.5 divided by the opposite of the log of 2. Now that's an exact answer. Now if this were an application problem, I would want an approximate answer. And the approximate answer is negative 0.5850. Personally, we're looking at what do I expect on the test. This would be fine. I'd stop while I was ahead. Application problem, I need a number. Solve an equation, don't need a number. This is a better answer than this one is anyway. Why? Because it's got, at this point, it is exact. And I can take it then to as many accurate decimal places as I need to. Now on this one, this is the factor that has the x in it. That means I need to isolate this, so I need to divide both sides by 0.3, so that for the 0.02x equals 0.2 divided by 0.3, that's just 2/3. How did I get 2/3? How would you get 2/3 from 0.2 divided by 0.3? Any ideas? Just removing the decimal, yeah. What I did is, since these are both to the 10th, just multiply top and bottom by 10. That moved the decimal over, so now I don't have to worry about a 0.2 divided by 0.3. Would it be wrong if you left it 0.2 divided by 0.3? No. You'll get the same answer. It's just you have more decimal points to worry about. Either way. Now, what do we do? Well, I can't make the bases to be the same. So I'm going to take the log of both sides. So the log of the left-hand side is equal to the log of the right-hand side. So if the two things are equal, then the log of those two things are equal. Now, bring the exponent down in front, using properties of logarithms. 0.02x log of 4 equals the log of 2/3. I want x, log of 2/3 is a number, log of 4 is a number. So I just want x, that means I divide both sides by everything that's not an x. 0.02 log of 4, 0.02 log of 4. So that tells me that x is the log of 2/3 divided by 0.02 log of 4. Now again, that's your exact answer. If I want an approximate answer, x is approximately, why did I do that? Don't know. Negative 14.6241. So that's your approximate answer. The more exponents you have, the worse the problem is. Don't have a choice. Any questions?
Can you put that in the calculator?
Yeah, I was just looking.
Sure.
Thank you.
Let's see, I could be wrong. Who knows? I did this while I was still on leave. At my dining room table, so. Let's see, where am I? Log of 2/3 divided by, now that denominator I need to put in parentheses, 0.02 log of 4, which is interesting because log of 4 is negative, log of 2/3 is negative, negative divided by negative should be positive. Let's see. Oh, nope, I'm right. You could do it in pieces. That would be fine too. But if you do the whole thing,
Right, because the 0.02 is going to become an exponent in the log, right?
what will happen is, without this parenthesis, this whole thing becomes divide, and that moves into the exponent. Without this parenthesis, then order of operations would say that what you would have, I need some space here, would be the log of 2/3 divided by 0.02 log of 4. So without those parentheses in the bottom here, order of operations would take the log of 2/3, divide that by 0.02, and then multiply the whole thing by the log of 4. And without the parenthesis here, then this whole thing you're going to be taking the log of. Because it'll bring that in. This closes out what you're taking the log of. Divide then starts another operation. And then with this thing, numerator, denominator. Now if you're in math print on your calculator, and you have math print on your calculator, then as you put it in, you'll see what it's going to look like, and you'll see whether or not it looks right. Does it look that way? Now, this is where things get ugly. The more exponents you have, the worse it is. Here I have an exponent of x plus 1. Here there's an exponent of 1 minus 2x. I put those in parentheses, as they should be, because they are. And I noticed that my former college algebra student, who comes visits me just about every day on his way to calculus, and every now and then he'll come and sit in my office and do homework and then show me some stuff. But he's now learned to put parentheses in. Because here's what happens. Those two things are equal, so that means the log of those two things also must be equal. And we're taking the log of 2 to the x plus 1 and 5 to the 1 minus 2x. Now when I bring that exponent down, and I say x plus 1 log of 2, this is not x plus 1 times log of 2. It's not what it is. Because when this exponent comes down, it comes down as a single entity. There's a set of parentheses there. It's that exponent times that logarithm. And that makes a difference. Now, why is that going to make a difference? Distributive property. I'm going to have to distribute the log of 2 through. So that means this exponent has a set of parentheses. So when it comes down, it's going to be 1 minus 2x log of 5. Again, without the parentheses, it would be 1 subtract 2x times the log of 5. That's what order of opposites would say. If you try to put it in your calculator, that's the order it would do it without the parentheses. So the parentheses need to be there. Now at this stage, log of 2 is a number, log of 5 is a number. And for you guys, I wouldn't have a problem if you went ahead, changed the log of 2 to, say, 4 decimal places, 0.301. So 0.3010, but a 0.301, and worked it that way. Because it's just a number. And the log of 5 is 0.698 or 0.699, if you wanted to go that far, and to do that. It might make your life easier because you're dealing with numbers. You're becoming big people now, so I'm going to work it through in all its ugly glory. Distributive property would say that this is x log of 2 plus 1 log of 2 equals 1 log of 5 minus 2x log of 5. Like in solving any equation, you move anything term that has an x to one side and anything that doesn't have it to the other side. It'll be kind of like when you're finding the inverse that you have to do. So I'm going to add 2x log of 5 to both sides. So this says x log of 2 plus 2x log of 5 plus log of 2 equals log of 5. Now, I'm not going to ask if we're having fun yet because these problems are not fun. They're tedious. But welcome to the world of mathematics, and the further along you go, the worse it gets. So now I'm going to move the log of 2 over. So I get x log of 2 plus 2x log of 5 equals log of 5 subtract log of 2. Now again, if you change log of 5 and log of 2 to decimal numbers, everything would be down decimals. And you would be adding and subtracting decimals. What you notice is I have a greatest common factor of x. So that x times log of 2 plus 2 log 5 equals log of 5 subtract log of 2. And like with anything else, you want to get x by itself. So you're going to divide both sides by log of 2 plus 2 log 5. Remember, it's just a decimal number. Log of 2 plus 2 log 5. So the exact answer for this sucker is log of 5 minus log of 2 divided by log of 2 plus 2 log of 5. Now that is the worst that you'll see in your homework. And by the way, this is approximately 0.2342. Now, I don't know if you changed it to 4 decimal places. I think you should be okay in your final answer to at least 2, if not 3, if you worked your problem using 4, because of rounding. Because of rounding. Not fun.